Today is October 9th, 2008, and we're at the headquarters of Pure Aqua Incorporated in Santa Ana, California, United States of America. And we're going to describe an SW15K seawater reverse osmosis system shipping today to Yemen. The system is designed to treat feed water up to 42,000 ppm and produce, as I said, approximately 15,000 gallons per day at a temperature of 25 degrees C, feed water temperature. We begin with the inlet port here, where the feed water enters the RO system, and we have an electric ball valve here that opens, permitting feed to enter the system. And once that happens, or that begins by pressing the power button here on the microprocessor control panel. But once that opens, feed water enters the system, and assuming there's sufficient pressure as determined by a pressure switch, this motor and pump will start and begin to boost pressure of the feed up to approximately 900 psi in the system, and then feed water through this stainless steel feed pipe that is a duplex stainless, highly resistant to corrosion. It will enter the pressure vessel, which incidentally is rated to 1,000 psi and manufactured by Protec Pressure Vessels, United States. Again, the feed water is boosted up to approximately 900 psi, enters the pressure vessel at this point here. Inside this pressure vessel, you'll have 4 SWC5 seawater reverse osmosis membrane elements manufactured by Hydronautics, again in California, United States of America. And once the feed water enters the pressure vessel and the membranes, you have a control valve here with a blue handle on it, at which point you close to increase the pressure within the system and basically force feed through the membrane elements. As you do that, you monitor flows here on the control panel. You have a reject flow and you have a product flow. As you close that valve, not only does the system pressure increase, and you read that pressure incidentally, you can read the pressure there at the reject pressure, or similarly at your feed pressure here, which is the initial pump pressure. But as you close that valve, you're going to force more water through the membrane, making more permeate, increasing system pressure, and then you monitor these flows, the reject and the product, relative to one another. The system is controlled by a microprocessor, and it's also equipped with a programmable variable frequency drive that can be used to control the pump within certain guidelines, depending on things like temperature and pressure. And then to keep the system as corrosion-free as possible, the system's also equipped with a fresh water flush option. Right here you see a solenoid valve that permits fresh water into the system. This would be done, of course, while the system's not running, producing a permeate water, but that would literally flush the system of the seawater for periods of time when the system's down, to prevent corrosion from the seawater setting in the system.